Today we're looking at the unit circle. We introduced the angles here briefly yesterday with the 30, 60, 90 triangles. We didn't look at them in terms of radians, but we were looking at a 45 degree or a 30 degree or a 60 degree reference angle and the coordinate points that they would generate in those four quadrants around the circle, right? So we're taking all that information and we're layering it together, and that's what you're looking at right here. So they filled in pretty much everything here for us. So notice these are the coordinate points that we had identified yesterday as coming from those special right triangles. Also, the radius of this is a radius of 1. That's what the unit circle is. And that means that this point on the far right-hand side is 1, 0. At the top, 0, 1. On the left, -1, 0. And at the bottom, 0, -1. So that's because the radius is 1. If you take a look at the degree measurements, take a look at the intervals of 30 degrees. So if you take a 30, 60, 90 triangle and you put it right here, the idea is that you can stack one, you could stack a second one here, and then a third one here. So there's 3 of those 30 degree angles that you could put inside this 90 degree angle. And you could put another 3 here. So you have a 6 total 30 degree angles on the top, another 6 on the bottom. So we're looking at these here. So this is 30 degrees, add another 30, you get 60, add another 30, you get 90, keep adding 30, you get 120, and then 150, and then 180. Keep adding 30 degrees, you get 210, 240, 270, 300, 330, and 360. So when you're filling these out, I know this one is pre-filled out, but when you're filling these out, you're looking for these patterns. And yesterday we talked about the patterns of these ordered pairs. Now we're looking at the patterns in the angles. So in the same way that we had counted by 30 degrees, now we're going to count in terms of 1/6 of a pi. Remember, half of a revolution is 1 pi. That means if you divide that into 6 equal parts, the smallest is 1/6 of a pi. So let's go around and count those same angles, but now in radian measured. So there's 1/6 of a pi. There's 2/6. Notice 2/6 is reduced to 1/3. So that's 2/6 of a pi. There's 3/6 of a pi reduced. There's 4/6 reduced to 2/3. There's 5/6 of a pi, and there's your 6/6 of a pi. Let's keep going. There's your 7/6 of a pi. 8/6 of a pi reduced to 4/3. 9/6 of a pi reduced to 3/2. 10/6 of a pi reduced to 5/3. And there's your 11/6 pi. And we return to where we started from. There's your 12/6 of a pi that we've reduced to 2 pi. So you can see this fraction work is one where we're always having to think, how many 6 of a pi do we have, but then reducing when we can reduce. If you take a look at the 45 degree angles now, this is our 45, 45, 90 triangle that we're thinking of right here. Right, 45 plus another 45 is 90, plus another 45 is 135. Keep adding 45 degrees. You get to 180, then 225, then 270, 315, and back to 360. So let's think of that in terms of radians now. If this is pi radians with half of a revolution, we want to divide that into 4 equal parts. And that's where we get 1/4 of a pi at 45 degrees. So this is 1/4 pi. 2/4 pi, again, reduced to pi over 2. 3/4 pi. 4/4 pi is reduced. 5/4 pi. Here's your 6/4 pi, which is reduced. 7/4 pi, and then 8/4 pi. So when you're filling these out yourself, you want to look for those patterns and sort of count up the degrees and count up the radians as you go around, reducing the fractions as you go. We're taking it a step farther now, and we're looking to see how we can associate these ordered pairs with our trig functions. We're talking about the sine, the cosine, and the tangent. You've learned this phrase at some point, SOHCAHTOA. It's a memory device. S stands for sine, C stands for cosine, and T for tangent. That's what I've written down right here. So the first letter is sine. The next 2 letters describes the ratio of 2 sides of a triangle. Remember, we have a triangle that we have inserted into the unit circle, right? And so we're just pulling that triangle out because we can then label it up with more numbers and more information. So we have a ratio of 2 sides called sine. The 2 sides are the opposite side and the hypotenuse. we have a ratio of two sides called a cosine. That's the adjacent over the hypotenuse. So these letters are the first letters of each of those words. So there's your adjacent and there's your hypotenuse. The tangent ratio is the opposite over the adjacent, so opposite and adjacent. So you have to identify your reference angle. Here it is. There's your initial side of the angle. There's your terminal side of the angle. That's your central angle. We call that a reference angle. And that means that if you have the hypotenuse, it's going to be on the terminal side, and that'll be opposite the right angle. That means you have two legs. The adjacent leg is touching the reference angle, and the opposite leg is on the opposite side of the reference angle. It is not touching the reference angle. So we're using a 30, 60, 90 to illustrate this, which is also the pi over 6 angle measure. And because of the 30, 60, 90, we know that this ordered pair on the unit circle is the root 3 over 2 comma 1/2. So that's what we are referencing right here. And we know that x coordinate is the base of the triangle. So the long leg of that triangle, which is the adjacent side, adjacent to the reference angle, has a length of root 3 over 2. The opposite leg, which is the height, is the 1/2. So when we're looking at a ratio of two sides, we need two sides. We need two numbers. So if we're looking at not just the numbers here, but which sides we're picking, if we're using the sine ratio, that's opposite over hypotenuse, the opposite is measuring the height. So that's your y value, your y coordinate, and the hypotenuse is the radius. So it's y over r. Now because we're on the unit circle, the radius is just 1. So it's y over 1, which is just the y coordinate. In the cosine ratio, we want the adjacent over the hypotenuse. So the adjacent is the x coordinate over the radius. Again, the radius is just 1. And then for the tangent ratio, we want opposite over adjacent. So that's going to be the y coordinate over the x coordinate. So we can either think of the x and y coordinates as being the lengths of the sides of the triangle, or we can go to the ordered pair and identify the x coordinate here and the y coordinate there. So we'll do some examples of that kind of thinking down here in just a moment. So another way to think of that ordered pair is we're saying, hey, you know, that x coordinate that I'm using is really just x because the radius is just 1, right? So that x coordinate that I'm using is associated with cosine. So another way to think about that is you're taking your radius and you're multiplying that by the cosine. And the y coordinate, again, your radius is just 1, so the y coordinate is associated with the sine. So you could think of that as like the radius times the sine. So that's one way to think of these ordered pairs. So when we say what is the cosine, you can associate that with the x coordinate. When we say what is the sine, you can associate that with the y coordinate. And when we say tangent, well, you need both. You need both y and x coordinates, and you set it up like this. So let's evaluate the sine, the cosine, the tangent of some of these reference angles. So here is 7/6 pi in our first example. You can see it is, there it is, okay. But if you lose track of it, look at the denominator. It's a sixth of a pi, so count in terms of sixths of a pi. 1, 6, 2, 6, 3, 6. 4, 6, 5, 6, 6, 6, and there's your 7/6 of the pi. So that way you can kind of find it if you lose track of it. What we want is that ordered pair. All right, so that's what we're looking at. Remember, this is your x coordinate, and this is your y coordinate. X is associated with cosine, and y is associated with sine. So the cosine of 7/6 pi, and we put that in parentheses just to say that's our input, and the output is the x coordinate, which is the negative root 3 over 2. The sine of 7/6 pi is the y coordinate, negative 1/2. Tangent of 7/6 pi is, well, that's y over x. We need the y coordinate divided by the x coordinate. So we're going to have negative 1/2 divided by negative root 3 over 2. Well, we need to simplify that, of course. So think of that as negative 1/2 times the reciprocal. So negative 2 over root 3. So we'll have a positive value, of course. These 2's cancel out, it looks like you have a 1 over root 3, but no, we have to rationalize the denominator, so final result is root 3 over 3. So that took a little bit of calculation to figure out. That's the result of the ratio of the y-coordinate to the x-coordinate as tangent. All right, let's take a look at another one here. Here is number 2. Let's see if we can fit this in this little space. This is negative 4/3. So now remember, if you have a negative angle, that means you have to rotate in the clockwise direction. And let's count in terms of third of a pi. Normally, positive 1/3 pi would be right there. So that's a third of a pi in the positive direction. Let's go in the negative direction. So there's negative 1/3 pi, negative 2/3 pi, negative 3/3 pi. There's negative 4/3 pi. So we're looking at this ordered pair right here, okay? So my cosine of negative 4/3 pi is the x-coordinate, which is negative 1/2. My sine of negative 4/3 pi is the y-coordinate, root 3 over 2. And then the tangent of negative 4/3 pi, that's going to be the y over the x. So we have a root 3 over 2 divided by negative 1/2. Notice both of these denominators have the same 2, so a shortcut is to just cancel out both denominators, and that gives you a result of negative root 3. We could have done that over here if we had picked up on that, right? Notice both of those denominators have the same denominator of 2. We could cancel that out directly and jump to this step. You'd have a 1 on the top, a root 3 on the bottom, and then you still have to rationalize. Here's number 3. We have a central angle of 7/4 pi. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Again, you can count in case you lose track of where those numbers are. These are the ordered pairs. This is the ordered pair. These are the coordinates. So here we go. Cosine of 7/4 pi is the x-coordinate, which is root 2 over 2. Sine of 7/4 pi, negative root 2 over 2. And then tangent of 7/4 pi. Now notice they're exactly the same, they just differ by a sign. So that means they'll cancel themselves out and leave you with a negative 1. All right, and in the last example here, we'll go back to a negative angle of rotation. So we want a negative 3/2 pi. So starting here, rotating clockwise, negative 1/2 pi, 2/2 pi. There's negative 3/2 pi at the top. So we're using 0, 1. So cosine of negative 3/2 pi is associated with the x-coordinate. Sine of negative 3/2 pi associated with the y-coordinate. And then tangent of negative 3/2 pi, well, that's y over x. And so that means we have 1 over 0, and you can't divide by 0, so that's undefined. So we're continuing the same kind of thinking down here below. It's just that we are now expanding our trig functions to include another 3. So we have 6 altogether. All right, so in the left-hand column, you have your original 3, sine, cosine, tangent, and they're trying to show you the abbreviation, right? So you just use the first 3 letters, but you don't call it sin, you don't call it cos, you don't call it tan, you still pronounce it the full word sine, cosine, tangent. That is the same as what we've seen before, right? Sine is still opposite over hypotenuse, and so on. So what we're doing here is we're essentially using this column of information right there. We're just kind of copying that and including it down here. So we said sine can be thought of as that y-coordinate over r, which of course in our case on the unit circle, the radius is just 1. So we say sine is, well, it's equal to y, but we have to be careful here because we'll be moving ahead in the days to come where our triangles are not going to be on the unit circle. That means we won't have a radius of 1. So we can't just say sine is always y. It's always the ratio of 2 sides. It's always the ratio of 2 sides. It's just that here we have a side of length 1. All right, so cosine, that's our x-coordinate over the r, which again is x over 1. And we said tangent is y over x. And that works as long as you're not dividing by 0. Those are the original 3 that we've memorized from that phrase SOHCAHTOA. Now we want their reciprocals. So the reciprocal of sine is cosecant. That means you have r over y. Now, and again, we have a radius of 1, so that would be 1 over y. So it's literally the reciprocal of the y coordinate. The reciprocal of cosine is secant, so that's r over x. But again, the radius is 1, so it's the reciprocal of the x coordinate, which is 1 over x. And the reciprocal of tangent is cotangent, and so that's going to be the x coordinate over the y coordinate. Again, you can't divide by 0. So let's see if we can find all 6 trig functions related to some of these angles. Here, let's start off with 7/3 pi. So we need to know, what is that ordered pair at 7/3 pi? So our reference unit circle here in our notes: 1/3 pi, 2/3, 3/3, 4/3, 5/3, 6/3. We have to go around again. 7/3. So there it is. We're back to quadrant 1. 7/3 is the same as 1/3 pi. So that's the ordered pair we want to use, and I'm just jotting it down again here for reference so I don't have to keep moving the paper back and forth. Okay, notice the order in which they have set it up. They start with sine and then they go to cosine. So sine, that's associated with your y coordinate, so root 3 over 2. And then the reciprocal will be 2 over root 3. But you have to rationalize the denominator. Right, so that's what we're thinking, and the result of that is 2 root 3 over 3. Cosine is associated with the x coordinate, so that's going to be your 1/2. Reciprocate that. That's easy enough. Tangent is the y over the x. So you have a root 3 over 2 divided by 1/2. Again, remember those 2's cancel out, and so you're left with root 3. We reciprocate that, we get 1 over root 3. Rationalize your denominator. So root 3 over 3 is the result. Let's do a central angle of pi. All right, we know where that is, right? So pi is here. The ordered pair is -1, 0. And so let me jot that down. X comma y equals -1, 0. All right, sine is associated with, do you remember? The y coordinate, 0. What's the reciprocal of 0? 1 over 0, which is undefined. Cosine is associated with the x coordinate. The reciprocal of that is still -1. And then tangent is y over x. So 0 over -1, which is 0. The reciprocal of that is -1 over 0. You can't divide by 0, so again we have undefined. Okay, here's our last one. -3/4 pi. We want to find what that ordered pair is. Remember, we're going in the clockwise direction now. So here's -1/4 pi, -2/4 pi, -3/4 pi. Here we are, we're in quadrant 3. So that means we have -√2 over 2, comma, -√2 over 2. Okay, the sine coordinate, the sine associates with the y coordinate. The cosine is the same. That's the x coordinate. The tangent is y over the x, so they're the same, right? So you'll get a +1 as a result. And then reciprocate each of those. So you flip that upside down, you have a -2 over √2, and again we rationalize. So we end up with the result of, so think about this here now. You have a -2 times a √2, but then on the bottom, √2 times √2 is a normal 2. You can reduce that fraction. Those 2's cancel out. The final answer is a -√2. And that'll be the same for the x coordinate, so your secant is -√2. And then for the cotangent, you reciprocate the 1, and you get 1. So your homework is going to be just practicing these. Some of the problems will say just find the sine, cosine, and the tangent. Others will say find all 6, so just pay attention to how many of those trig functions they're asking for.